Hi guys, this is Mrs. Gastler, and in this video we're going to talk about V versus T graphs with constant acceleration. So I've got my notes page here. Yours might look a little bit different, and that's okay. We're going to start by drawing some position versus time graphs, which is a review of the previous lesson, and then we'll write some descriptions and motion diagrams and turn those into velocity versus time graphs. So to begin with, remember there's two different kinds of motions we could be or not two different, four different kinds of motions. We could be moving in the positive direction, and we can do that for two of these, direction, or we could be moving in the negative direction. Okay, so that's the other two that we could do here, negative direction, and we could be speeding up in two of those in opposite directions, and we could be slowing down in two of those in opposite directions. So we'll draw all of those, and then we will look for some similarities. So we already looked at the position versus time graphs previously. Remember, if you're going in the positive direction, it's going up. Speeding up means it's getting steeper, so that looks like this. Moving in the positive direction and slowing down means you got to start steep and get less steep. Same thing for, whoops, I forgot the up. Moving in the negative direction just means we're going down. So if we're speeding up, we're going to start out flat and get steeper. Okay, remember these kind of do the opposite. And moving in the negative direction, we're going to start out, and slowing down, we're going to start out steep and get less steep. So like this. So those are going to do the opposite. In our motion diagrams, we always start with a number line. Remember to start with a number line. Even if you don't put any numbers on it, you need a number line. Whether it has 0 marked on it or not is not all that important to me, but it might be important to your teacher, so make sure. If we're going in the positive direction and speeding up, our dots are going to start out close together and get farther apart, and our arrows are going to point to the right, like this. And our acceleration arrows are in the same direction because we're adding to the velocity each time we go. Okay. When we're slowing down, they start out far and they get closer together, which is harder to draw for me. I don't know about you. They're still going to the right, but this time we are subtracting from our velocity to make it smaller, so our acceleration arrows point in the opposite direction. Similarly, in the other direction, we're going to start out close together and get farther apart, but going in the negative direction. So we'll have short arrows that get longer, like this, and our acceleration adds to it, so those are going to go point in the same direction. Moving in the direction and slowing down means we're going to have our dots farther apart, and they're going to get closer together, like that. And our arrows will start out long and get shorter and shorter and shorter. And so because we're getting smaller, our acceleration is going to be subtracting, so it has to go in the opposite direction, like so. Okay? So I like to take the motion diagram and use it to think about the velocity versus time graphs, just like I did with the constant velocity ones. I'm going to take my little arrows and I'm going to stack them up over here. So I start with a short arrow, and then I have a slightly longer arrow, and a little bit longer than that, and a little bit longer than that, and a little bit longer than that. And then when I make my graph, because these arrows are not actually the graph, it's going to go up like this. Okay, so this line right there is what I'm looking for. Maybe I should draw this in pencil so you can see it a little bit better. This time my arrows are going to start out tall. Okay, remember this is the positive direction and this is the negative direction. So since I'm going in the positive direction, I need to make them point up. Okay, the arrows have to point up. And they start out long and they get shorter and shorter and shorter and shorter and shorter. And so this is what my line looks like. You don't have to draw the arrows, but if it helps you see the line, go right ahead. It's a reasonable thing to do. Now with the negative, going in the negative direction, my arrows are going to point down. So let's say I'm going to start out with a short arrow because I'm going to the left here, and a longer arrow, and a longer arrow, and here I went back to my pen again, and a longer arrow, and so on. And so you can see that my line goes down like that, okay? And let me draw it this way. With the pencil here. So now I'm still going down, but this time I start with a long arrow and a shorter arrow and a shorter arrow and a shorter arrow. And so my line goes like this. I didn't draw those arrows very good, okay? But focus on that line and not on the arrows, because a velocity versus time graph is the line. The arrows are just there to help us think about what that line should look like, okay? So let's see what similarities they have. Okay, so we've got going in the positive direction. Notice how they're both above the time axis. And in the negative direction, they're both below the time axis. We saw that with constant velocity anyway. So that's not anything new. And then let's look at speeding up. Speeding up, notice how they both go away from the time axis there. See how they're going up like this? Well, away. Well, this one's going up and this one's going up, so we're going away like that. And then slowing down, they're coming toward that zero, toward that time axis like this. So we can't use going up and going down to be something useful, because it really depends on whether it's on the negative side or the positive side as to what that means. So you're going to have to think about two different things here. Is it above the axis or below the axis? Is it going away from the axis or toward the axis? That's the way you're going to figure out what's happening with a velocity versus time graph. Okay. There's the practice. If you have any more questions, make sure you ask your teacher. Thanks for watching.